Well, good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up number 31 is on the screen. Let's get started, please. And today we're moving on, so everybody go like this really quick. Bear with me. Let's go. Oh, yeah. Gonna go fast, guys, so let's keep at it. Copy that and go. Whoa. All right. So for number one, let's see, today's Thursday. By now you should be able to do these by yourself. I'm going to have Rylan help me out with 1A. How do we rewrite 12, Rylan? Yeah, so he said 12 becomes 2 times 2 times 3. Yes? How about 40? What'd you get for 40, Jacob? How do you rewrite 40? Yes, 2 times 2 times 2 times 5. That is correct. Giant ones. And we're left with 3 over 10. Hands if you got that. All right. And once again, yes, we want the simplification, but I want to see the process. Because you're going to see today as to why we use this process. We're going to get started. Let's go to number 2. Can we factor the numerator? Tell your neighbor, what's GCF for the numerator? What would be our GCF for the numerator? Everyone? X. And we're left with 2x plus 1. All right. Tell your neighbor the GCF for the denominator. X. And we're left with x minus 15. Do we have a giant 1? Yes, x over x. Why can we get rid of it? Because there's multiplication here and here. That leaves us with 2x plus 1 over x minus 15. Tell your neighbor why we cannot take this x and this x away. Tell your neighbor why we can't. Why can't we do a giant 1 there? Some of you said because there's no multiplication and because there's what? Addition or subtraction. We cannot take away that x because there's addition and subtraction. Let's go to number 2. Factors. What are your factors? Tell your neighbor your factors, please. Factors for number 2. All right. Think we got it? How about Brandon, Felix? What'd you get? X plus 2, x minus 9. Hands if you got that. That is correct. Number 3. What are your factors for number 3? Tell your neighbor, please, factors for number 3. All right. Factors for number 3. Laura. Okay, let's see what you get. Okay. 3x squared plus 2. Plus 2. Hands if you got that. That is correct. Yes. All right. Number 4. Y equals to what? What do you get for this one? Y equals to what? Dom. Negative 5x plus 4. Hands if you got that. That is correct. If I substitute -1 for the x, y equals that -1 times -5 is 5 plus 4, that is 9. If I substitute 0 for x, -5 times 0 is 0, and that leaves us with y equals to 4. And last but not least, if I substitute 1 for x, what is 1 times -5? -5 plus 4, that's -1. Hands if you got that by yourself. All right, we're getting there. Let's go. We got this. Next, tell your neighbor, what GCF did you use to get started for these denominators? What was your GCF? What GCF did you use? All right, Anthony E. What GCF? 2 and 2. Hands, have you got that? All right, so 2 times 5 and 2 times 3. Okay, so far so good. So, what does this one have that this one needs? The 5, so we multiply times 5, top and bottom. What does this one have now that this one needs? The 3. The 3. Therefore, my common denominator, 2 times 5 is 10 times 3, that's 30. 30. Numerators, 3 times 8, that's 24. 5 times 5, that's 25. Common denominator of 30. 24 plus 25, that's 49. And if you got that, some of you simplified, which is fine, but for right now, we'll leave it like that. I just want to make sure we're practicing the process. All right, copy the agenda, please. Warm-up number 31. We're moving on today to rational expressions. Rational expressions, and today we're simplifying. Now, I've already given you 2 weeks of practice with these. Hopefully, actually, I think 1 week, which is pretty good. And you're going to see how we pretty much already did half the work, okay? And like I said, that's how it's going to go on for the rest of the year. Make sure you're doing your warm-up because you're going to have a lot of practice before we get to the main sessions. And your home play for tonight is problems 1 through 15, evens only of that play sheet. And I'll show you the play sheet in a little bit. And last night you had home play, so turn that in on Canvas, please. And get a Cornell note ready. And here's your Nearpod code for the home play tonight. XDPE. 3XDPE. 3XDPE. All right. So once again, last night's home play was those 6 problems. Tonight's home play, only those. You're like, what, Mr. Q? Fractions with polynomials? Oh, yes. We got this. Let's go. All right, get a Cornell note ready, please. Once again, you do need a fair amount. I'll give you a minute to turn in your home play and get your Cornell note ready. And it reads, I can simplify rational expressions. So we're moving on today. We're going to be simplifying, and we're going taking a step back to expressions. Yesterday and the day before we did equations. Is that correct? All right, so rational expressions. Write that in there, please. What are they? Rational expressions. They are algebraic expressions whose numerator and denominator are polynomials. Algebraic expressions whose numerator and denominator are polynomials. Let me repeat that again. Algebraic expressions whose numerator and denominator are polynomials. What are they implying in the definition when they say numerator and denominator? Tell your neighbor, what do they imply? Yeah, that we're going to be looking at fractions with polynomials. Let's go. I'm telling you guys, polynomials aren't leaving. It's like that little person in your life. You guys have a little person? Like a little cousin or a little brother, sister? You're eating your hot Cheetos? I want hot Cheetos. And you have to give them your hot Cheetos. Or you're playing the game, and guess what? I want to, oh my goodness. So there you go, polynomials. I want to learn polynomials. Never mind. Anyways, so picture it, fractions with what? Polynomials. Examples. Write these down, please. 6 over g plus 4, 2x plus 1 over x squared minus 15x, 2x plus 6 over x squared plus 5x plus 6. And if you notice, these shouldn't come as a shock to you because we've been using these on the warm-ups. Thank you, Mr. Q. You're welcome. I got you. Oh, yeah. Look at them. Do we have a numerator and denominator? Yes. Are they polynomials? Yes. So they should have some sort of polynomial in that fraction. Okay. So look at this one. Look at this one. Look at this one. Fractions with polynomials. Okay. Look at the non-examples. Don't copy them. And tell your neighbor why, obviously, those are not rational expressions. Why are they not rational expressions? All right. Brandon, Darty, why are they not rational expressions? Because of the equal sign. So these are equations. So let me give you the hashtags. Write these down. Hashtag, they have to be a what? Algebraic expression. And hashtag, you need to see polynomials in the numerator and denominator. We'll just write polynomials, numerator, denominator. All right? All right. So, questions with rationals? No? Students, rationals, rational students? Like I said, some of you already seen these before, but maybe they haven't presented in this way. I like to present the main idea like this so you can see the difference, what it is, what is not. So there you go. Steps. Well, actually, definition. Look up. Don't copy this. You're like, what is that? Well, let me read it to you. Y'all ready? It says, Q stands for Quintanilla, yes. But in this case, I'm going to use it as a quotient, which means a solution to a division. And what are fractions? It's division, isn't it? Numerator divided by a denominator. So it reads, the set of all fractions, let me repeat that again, the set of all fractions where m is the numerator and n is the denominator, where m and n are z's. What are z's? Integers. Think about it. What are integers? Oh, all positive numbers and their opposites, and negative numbers. Except for what? 0 cannot be an n or the denominator. You're like, oh, I'm actually able to follow, yes. So you don't have to copy the definition, but that's where fractions come from. What are we going to be doing today? Simplifying, yes, but this is the second thing. We're going to talk about excluded values. What does that mean, Mr. Q? Well, think about this. Look up to the screen. I have this fraction m over n, and we cannot use 0. So that means that's our what? Excluded value, because we cannot use it. We have to exclude it. Why? Because of the definition. Okay? So, we're going to start slow. We're going to do two things today. Find the excluded value and simplify. We already know how to simplify because we've been doing that on the warm-up. I just wanted to walk us there. So copy this, please. Oh, not the steps. The steps, I'm going to leave them on the right-hand side, but here's the process. Don't copy this. You'll have the code for that. Identify excluded values. We're going to factor completely numerator and denominator, and then identify the what? Giant ones. Have we been doing that? Yes. All right. Copy this one. Example number 1. Identify the excluded values. Write the instructions, please. Then simplify to lowest terms. Identify the excluded value. Then simplify to lowest terms. And like I said, we already know how to simplify. Today we're just going to make sure we get plenty of practice. But I do want to address excluded values. Copy that. I'll give you some time. So here we go. First thing that I want you to do is identify the excluded value. So, look up to the screen. According to the definition that we saw earlier, let me bring that up. This one. What did this say? That denominator cannot be what? Denominator cannot be what? 0. Okay? So with that idea in mind, going to this problem, how do we know when the denominator becomes 0? By doing this. Writing utensil down. I'm going to do that in blue. Over here, I'm going to write it over here so like that you don't get confused with simplification. I'm going to write EV. What does EV stand for? Excluded value. So, what do I do for the excluded value, Mr. Q? Well, I need to set the denominator equal to 0. And then solve. So here we go. Minus 6 minus 6, you're just paying attention. Divide by 2, x equals negative 3. So what is my excluded value? Negative 3. What does that mean, Mr. Q? That I can use any number in here for x, except what number? Negative 3. Why? Because negative 3 makes the denominator what? 0. Let me double check. Give me a number, any number? 23. All right? So what is 23 times 2? 46 plus 6? 52. Is it equal to 0? No. However, what if I substitute negative 3? Let's see. What is negative 3 times 2? Plus 6? 0. That's why we cannot use 3. That's known as what? The excluded value. Copy that, please. All right, so once again, to find the excluded value, what do we do, Mr. Q? Well, you take the denominator and set it equal to 0 and solve. That's how you find the excluded value. Any questions? From 1 to 5, how comfortable are you with excluded values? Yeah, we got this, right? So, the second thing they want us to do is what? I'm going to switch to green. Simplify. So let's do this together. We already know how to do this, yes? Here we go. Numerator, can I factor this anymore? No, I'll just leave it as 2 times x. Denominator, can I factor this? Yes. What's GCF? 2, and we're left with x plus 3. And the last step, identify any giant ones. We have giant ones? The 2 and the 2, so we're left with x over x plus 3. Copy that, please. And that is simplified. Have we been doing that for the warm-ups? Yes, Mr. Q. Thank you for giving us a heads up. I got you. Yeah, good thing you did your practice, right? Practice? Practice? Who remembers that one? Any of you? No? Doesn't ring a bell? Yeah. Practice? Come on. No? Anyway. All right. So, excluded value, we know how to do that. Do we know how to simplify? Yes. All right. See if you can do this one by yourself. Example 1Q. 6x over 3x plus 9. Do both things. Find me the excluded value, and then simplify to lowest terms. Go. I'll give you some time. What did they get for the excluded value? All right. Excluded value. What was that number? Anthony E. Negative 3. Hands, you got negative 3. Let's see. I take the denominator. Set it equal to 0. Solve. Minus 9 minus 9. 3x equals negative 9. Divide by 3. X equals negative 3. Hands, if you got that. Okay. Next, simplify. How can we write the numerator in factored form? Numerator in factored form. Go. Martin. 2 times 3 times x. That is correct. 2 times 3 is 6 times x. Hands, have you got that? All right. How about the denominator? What is GCF for the denominator? 3, and we're left with x plus 3. The only thing we have left, identify giant ones. Any giant ones? Yes, the 3 and the 3. And that leaves us with 2x over x plus 3. Hands if you got that. Tell your neighbor why I can't do another giant one with the x. Why can't I do the x again as a giant one? Why can't we? Because there's what here, guys? Addition or subtraction. We can only do it when there's what? Multiplication involved. Okay? All right, from 1 to 5, how comfortable are you with this? Yeah, 5, 5, 5. Okay, let's do another one. Copy this. See if you can go a little bit faster now. You're like, what? No, we're going to do this one together. Example 1, super Q. We got x squared over x squared minus 5x. All right. Here we go. Start with the excluded value. Let's do this one together. EV. What do I write? Tell your neighbor. What do we write to get started? Brandon, Darty, what do I write? That is correct. We said the denominator equal to 0. Okay? So, whenever you have these guys, that there's a squared and a minus. Now check this out. Right away we want to do this to factor, square root, but we can't take the square root of 5. So let's start with doing the 2 steps. Standard form and GCF. Is there a GCF? Yes, what is that? X. So we do X. That leaves us with X minus 5 and all that equal to 0. Next, this times this equals to 0. So what should I write next? If this times this equals to 0, what do I write next? Dom? That is correct. Each of those equal to 0. It's our ZPP, yes? So, one of them's already solved. The other one, plus 5 plus 5, x equals 5. You're like, wait a minute, Mr. Q, what are you saying now? That now we have how many excluded values? 2, 0, and what is the other one? 5. All right. So, some of you are getting distracted with your Chromebooks. Close those, please. Thank you. Appreciate it. So we're done with excluded values. Let's go to simplify. How do we write the numerator in factored form? Yeah, x times x. How about the denominator? What's GCF? X, and we're left with x minus 5. Do we have a giant 1? Yes, x over x, and that leaves us with x over x minus 5. And we're done. Once again, remind your neighbor why we can't do another giant 1 at the end, please. Why can't we? Jacob, why can't we do another giant 1 at the end for the x's? There's a subtraction. That is correct. All right. Let's do another one of these. See if you can do this one by yourself. Very similar. Very similar. 2x over x squared plus 7x. Find me the excluded value or excluded values, and then simplify. Copy and go. All right, we're going to go back there to the back. I'm going to pick someone from the back. Excluded value. Tell me what to write, please, to get started. Trinity, tell me what to write. X squared plus 7x equals 0. Yes. What do I do from there, Anthony D? Factor. So what is our GCF? and we're left with x plus 7 equal to 0. Hands if you're up to right there. Okay, continue. Courtney Jean, what do I write next? That is correct. This is already solved. Minus 7 minus 7. X equals negative 7. Therefore, what are my excluded values? 0 and negative 7. Do we know what this means once again? Yes, Mr. Q, that we cannot substitute what two values in here? 0 or negative 7. Can we substitute anything else? Yes. 2, 3, 4, any number except what? 0 and negative 7. All right? Continue. Danny, how do I write the numerator? Oh, let me switch colors. 2 times x, and then? X times x plus 7. Hands if you got up to right there. And our giant 1, since there's multiplication here and here, so it's the x, and that leaves us with 2 over x plus 7. Hands if you got that. From 1 to 5, how comfortable are you with this so far? Okay, we got it. Let's crank it up a little bit. Yeah? You're on your beach cruiser over there in OB. Now your tires are on fire. Everything's on fire. Copy this one. Example 1 super duper Q. 6x squared minus 6x over 3x minus 3. 6x squared minus 6x over 3x minus 3. All right, I'll give you a head start. Let's see how you do by yourself. Your noodle should be able to take over from here. Should be on automatic pilot. Give some time, copy and go. All right. Let's see. Excluded value. Get me started, please. Excluded value. Maya, A, what do I write? 3x minus 3 equal to 0. Hands if you wrote that. Yes, and then we solve. Plus 3 plus 3. 3x equals 3. Divide by 3. X equals 1. My excluded value is 1. Hands if you got that. Okay. Step 2, which is simplify. Factor form of the numerator. What you get for factor form of the numerator? David. Okay, what's GCF of the numerator? 6x, and that leaves us with x minus 1. So far so good, yes? Look at the denominator. GCF of the denominator, everyone. 3, and that leaves us with x minus 1. Oh! You guys see the giant 1? Which is it? X minus 1. So watch, I'm going to do an actual giant 1 here. Bam. You guys see it? I got skills, I'm telling you. And that leaves us with what? 6x divided by 3, which is? What is 6x divided by 3? 2x. From 1 to 5, how comfortable are you with this so far? 5, 4, 5, 4. Okay, we're getting there. Okay. All right. Shall we? Yes, Mr. Q. All right. Too easy, very simple. Copy this one. Example 1 super. Yeah. Oh no, it's not super. 1 Star Wars Q. Star Wars Q. We got x squared minus 4 over x squared plus 3x plus 2. All right. Get us started, please. Kimberly, what do I write for my excluded value? Denominator equal to 0, yes. So it's x squared plus 3x plus 2 equal to 0. Does this look familiar? Yes, Mr. Q, we solved some of these yesterday and the day before. So tell your neighbor what to do from here. What shall we do from here? Can we factor at this point? Yes? What number goes on top? The 2. What number goes underneath? The 3. So, what numbers multiply to give me 2 that when you combine them or add them give us 3, everyone? 1 and 2. Okay. So, bring down the x squared, bring down the 2, and instead of 3x, we're going to write what? 1x and 2x. All right? Bring down the equal to 0, and let's group. First 2, bless you, second 2. So, what's GCF for these 2 now? X, will leave us x plus 1. What's GCF for the next 2? 2, and it leaves us x plus 1. So, what's the same here and here? X plus 1. What's left? X plus 2 equal to 0. So, question. If this times this equal to 0, tell your neighbor what to write next. If that times that equals to 0, what do we write next? Don, what do we write next? Yeah, x plus 1 equal to 0. X plus 2 equal to 0. Solve. So my excluded values are -1 and -2. All right. Let's go to simplifying this. Look up. Look at the numerator. Isn't this a difference of squares? Square root, square root. So what are my 2 factors? Tell your neighbor. 2 factors. +2 and -2. Can we factor this one? Yes, we already did, Mr. Q. What were those factors, guys? We already did the work over here, so it's what? X plus 1 and x plus 2. You guys see the work over here? Yes? So, giant 1. What is our giant 1, everyone? X plus 2. So we're left with x minus 2 over x plus 1. Hey, that's all that? Let's go. Tutoring after school, guys. Be there or be elsewhere. Have a good one. Enjoy your home play. See you guys tomorrow. Bye. There you go.